Hello, everyone. I'm going to share a current project that I'm working on. Very small design build. A customer of mine worked for years with them, called up a few months ago and asked if we could take a look at a lobby entrance that their staff uses, as well as their patients. That in the wintertime, they're experiencing a lot of heat loss with the doors opening and closing regularly. So they asked me to come out and take a look at what they had and come up with a solution for that. So I'm going to share with you what the detail looks like and what I came up with. So I first got there and looked above the ceiling, and there was no hot water system. There was steam and condensate existing, serving another fan coil unit. So I'm going to utilize the steam for it. So I reached out to Nick at Herman Products, and he came up with a solution of this powered air, steam driven air curtain. So we reviewed what the details submittal was for that and see how we could make that compatible with what we had. The obviously that air curtain is going to need a power source and a little bit of controls work. So I got in touch with Marcus at Billatier Electric. He's going to take care of the power and a little bit of the controls. So I'd like to run you through what's got to take place in order to get this thing operational. So first and foremost, we got to supply with steam and condensate. Then we're going to briefly touch on that, and then we'll get into the power. So the existing steam up in the ceiling is at 7 psi, serving the other fan coil unit. So I know I got that much on the pressure side, which will give us some help on lifting the condensate after it goes through the air curtain, which is what we got here. So we're going to pick up that steam here, add in a two-way control valve here that'll open and close as required to allow steam into the coil. And that condensate, after it goes through the coil, will get lifted up and head back to the common return. So there will be a steam condensate trap after the coil here that lifts up and out. And when that two-way valve is shut, we're adding in a low pressure F&T trap for to get rid of that condensate when that is closed. So for the steam side, that's what we'll be installing above the ceiling. We'll make these connections here, come up with an aesthetic shroud to cover the exposed piping. That's about it for the piping portion of it. Now the power. So the power is going to be coming from a panel in the room next door. This room's adjacent to a boiler room. In that boiler room, there's opportunities for grabbing power. So we're going to install a new breaker in that boiler room panel, and we will bring 208 input power up to a power disconnect above the ceiling. That disconnect will be the on and off to this air curtain. So I asked the supplier, Nick, to give me a wiring diagram for this that I looked at to see what on the controls side was going to make this work. So what's going to happen here is these two sliding doors are exterior doors that staff come in and out of frequently. And what that's going to look like is there will be a magnet switch on the slider. So there will be a magnet switch that gets mounted to that sliding door, that when that door opens, that switch will engage the air curtain. So when looking at the wiring diagram, you can see all these locations up here are defined by what the wiring diagram has them labeled. So this will be a 2-wire to that magnet switch. Our power wire has these 3 in the ground. Our control valve is 4 and 5, 2-way wire on the control valve. Oh, I'm mistaken. I'm sorry. A1 through 3, so it's 3-wire. All right, so that's great for that this will engage it. When the doors open, it will engage the air curtain, and the fan will turn on. Obviously, depending on what time of year that you're in, I think what we're going to have is the facility is going to want some options, meaning they're not always going to want steam. They're going to want steam when they need to heat, which is going to be wintertime. But in other times, like for instance, things to consider summertime when you want to keep the cooling in place and not let the heat from outside in. So sometimes there'll just be a fan function here, and the steam, despite it being utilized in the building for other needs, we're not going to want to push steam through that coil. So what we have going on the wall is a fan switch, which will be a high, low, or an off position. That's just going to be a manual toggle on the wall. And there's also going to be a thermostat. So in the case of, say, overnights, or perhaps sometime where the doors aren't opening frequently, we're going to set some boundaries on that thermostat, that if that space does need some supplemental heat, that will kick on the air curtain despite the doors being closed to help keep the space at the temperatures that they want. So this fan wall switch will just be a manual toggle, and the thermostat will be something that you could adjust as well. So the fan switch will be a 3-wire going back to these terminals at the COM board. The thermostat is going to be a 2-wire back there. So access is on the top of this unit. Conduits will go up above the ceiling. They'll run above the grid, and will come down the wall here to these surface mounted. So anyhow, I do believe this air curtain should be coming any day now. Looking forward to installing this, and appreciative for the customer to get us involved with this project. And thanks again for Herman coming up with a product, and Billatier helping out with the power. I will update you how on the install goes and what the finished product looks like. Thanks for watching.